Hey, in this video we'll be assembling the RAM board for the SCELBI 8B Minicomputer, which will, if you're just joining, we're assembling this computer right here. It's the SCELBI 8B. So we got pretty much all the boards in there already. The last board that we inserted and tested in the last video was the RAM board. So we basically tested and verified that the computer is operational, at least the part where basically we were able to insert a program into the computer and execute the program. So we verified that part, but we haven't actually tested the I/O ports, which we'll probably do in future videos when we assemble the peripheral boards. But the last board that goes inside the computer, aside from additional RAM boards, is this ROM board. And it's actually pretty basic. It has a couple of basic components, static components. Most of them are just ROM chips, and we'll be using these sockets right here. I think these are 24-pin sockets for the ROM chips. And let me actually open this manual here that I compiled. Let's go to the assembly instructions for the ROM board, which is in the assembly manual for the SCELBI computer. There's really not much here aside from the fact that this board right here actually uses type 1602 or 1702 proms, which you can read a little bit about them. I do have some right here. These are 1702s, and let's see, how many do I have? I have 10. Yeah, I got 10 of them. And this one here actually supports 16, so it's not going to completely fill up the entire ROM board. But the way that, so the idea is to actually program these ROM chips with the SCELBI programs, original SCELBI programs, so like the SCELBI monitor and things like that. And each program is, or each part of the program is actually stored on separate pages. So for example, each ROM chip here is basically a separate page, and we like, for example, cassette read interface will use page 1 or page 2 or something like that. I'm not exactly sure if that's the correct page, but that's how it works. So we're not going to use all the pages here. We'll just use some pages that will align with the peripheral boards that we have. So for example, we're not going to be using the oscilloscope functionality because I just don't have the board, and I'm not planning on building or assembling the board. So yeah, we're gonna assemble this board in this video. I'm gonna take out this parts placement for reference, and let me go all the way to the end of this manual here. Let's see, it actually requires positive 5 volts, 1.5 amp, and also negative 9 volts, 1.5 amp fuses. And there's really not much to it. It's pretty basic. It's a very basic board. Got the schematic right after that, and the parts list. So I got all the parts here. As I mentioned, I'm going to close this manual for now and get out of the way so it's not in our way. But as I mentioned, we'll be using these sockets here. I've been using these, I don't know what they're called. I guess somebody called them breakaway or breakout sockets, but they're just metal sockets that you insert into the position and to solder them in and then remove that plate. But in this case, I want to use these plastic ones, and these are, I think, pretty old as well. They're not modern, but the reason why I want to use these is because the prom chips might be added and removed, and those regular metal ones that I've been using, they probably wouldn't last very long if I keep on removing and adding the prom chips. We got 2 diodes here, a couple of resistors, fuse holder, sorry, not resistors, but capacitors, and that's pretty much it. So let's go ahead and start the assembly. I will start with the IC sockets. All right, looks good. I'm trying to face these IC sockets up so that pin 1 faces up, just how the layout has it here. All right, I guess the next thing we'll do is we will solder in the fuse holders. Simple as that. Let's do the Zener diode. And there's 2 of them. So one is a 12 volt and one is a 6.3 volt. I think this is a 12 volt here in this package. The 6.3 is in this package. Let's see if it'll actually fit, because I know in the other boards... Oh, it actually fits. Okay, interesting. I might have made these Zener diode holes bigger on this board for some reason. I don't even know why. But like, if it's too small, we'll drill it out like we did in the other ones. But in future boards, I'll try to make the holes bigger so that we don't have to do any drilling. I just want to make sure that they're oriented correctly. So the stripe for the 6.3 volt, actually I'm using a 6.2 volt, but the stripe faces up and the 12 volt one faces down. All right, the last thing are the capacitors. And that's it. So I guess the question now is, can we actually test this board? And the answer is yes and no. So first of all, yeah, we can actually brute force it, basically supply manual values into these prompt positions, and then see if it actually shows up or works on the computer itself, but it's just a little bit too much work. So the second approach is to actually use one of these prompts that we have here and insert into some of these pages here and see what we see, what is actually read on these prompts. So I don't think they're all reset. I mean, again, I'm just kind of guessing here, but I don't think they're reset. There's got to be some sort of data on there. I got them on eBay. I don't think the seller reset them. So my hope is that he didn't or she didn't reset them, and there's some data on it. So if there's no data at a specific memory address that we select on the SCELBI computer, then the value will be, most of the time it's just going to be garbage data, but usually it's just all ones or all highs. So if we actually insert one of these or a couple of these EEPROMs into the ROM positions and basically read from it, we should see some other value other than all ones from it. That's the idea. So I'm gonna give it a shot and see what happens. So let's see. I'm gonna insert into Z1 here position, just a random prom. Okay. And now we can insert it into the computer. So let me just put the computer right here. And the board, see, I don't think right now it doesn't matter where we place it. But like if we're going to be using the prompts created by SCELBI, I think it's assuming that the prompts or the prom board is actually located at the end. So we'll insert it at the end. Okay, so let me clean this up a little bit and hook up the power to it and give it a shot. I'm actually going to do a quick smoke test first. All right, it's running. We don't really have many components on the ROM board here, just a couple of capacitors and the Zener diodes and the fuse. So we're not going to see much activity on there, at least not much heat activity aside from this PROM here. Yeah, so it seems okay. Okay, so the way we're going to test it is we installed the PROM into Z1 of the ROM board, which is actually page 60 according to the documentation. So the high address would be set to 60 like this on the switches, and the low address 000 will basically address the first position in the ROM, and then we can just increment the low address using the switches here for the low part, but the high address will be 60. Z2 would have been 61, and so on. Basically, we can have up to 16, so we can select all the way to what is it, 77. That will be the last PROM on that board. So what I'm going to do first is I'm going to set the high address in the microprocessor to, instead of setting it to 60, I'm gonna first see what it actually shows on the 61 ROM, which we don't have anything installed there, and that's why I want to test it first. So what we're gonna do is we're gonna set the high address to, so that's the instruction for setting the high address. I'm gonna press interrupt and then step, and step one more time. Now it's going to wait for the high address, and we're going to set it to 61. Again, this slot here on the ROM board, the 61 position, is actually empty. We're going to press step, and we're going to set the low address, which is this instruction, to just 000. So we'll interrupt, step, and then set it to 0. And now we're going to execute an instruction to read the value at that memory location and just write it to register A, just for testing. So, and the reason why we want to do that is basically we want to see what data is being pulled from the memory location at that place. So the instruction is actually 307. We'll interrupt and then step, and we'll just step again. And right now it's just showing all ones, which is actually what we expected. But let me increment that address to basically 60 high address, and the low address will be 1 now. So let me step through that. And again, we're going to run 307 to read the value at that address. Did I interrupt? Step. Yeah. Again, we're seeing I guess it's 377 all ones, because there's no data in that location. We don't have a PROM there. But let's change the high address to so that's the command instruction for setting the high address. I'm going to interrupt, step, and I'm going to set it to 60 now, because I know that's where the PROM is, and we'll execute that. So now, right now, the address is actually set to 60 high address and 1, because we incremented the low address once. So let's read that location by executing 307, interrupt, and then step. Look at that. There's no data on it. But let's just increment it to see what if there's any data in the next address. So 307. Yeah, no data. Okay, well, at least we know that it's pulling the memory contents correctly from the right page, so that's good. I just don't know if that's the actual data or not, because I have no way of actually testing to see what's on the ROM board. Oh, sorry, on the ROM chip. So that'd be it for this video, since we have no way of actually reading or even programming the ROM chips at this moment. In the next video, we're going to build a programmer for the 1702. I think there might be some 1702 programmers available online if you really search around, and you might find some. They might be quite expensive. There might be even services for programming these chips, but I think I will rather build one myself. So we'll actually do it in the next video. Don't forget to like and subscribe if you haven't already, and I'll see you in the next video.